Hello everyone, in this video we're going to go over the last part of the final exam review. So question number 6 is about calculating the exact value with no decimal numbers for certain particular values of sine, cosine, and tangent. Most of this type of exercise depend of you using the double angle identities. So for example, sine of 15 is not something that we can calculate exactly, but we can calculate 15 as a difference between two angles that we don't know, two special angles, because we have the information of the special angles on the unit circle. So for example, we can use 45 and 30, and those are two special angles that we know from the unit circle. Now, using the double angle formula, we have that this is sine of 45, cosine of 30, minus sine of 30, cosine of 45. Now, once that I get this set up, I'm pretty much done. I should know that the sine and the cosine of 45 are square root of 2 over 2, since those are the most known sine and cosine, and cosine of 30 is a square root of 3 over 2, while the sine of 30 is just going to be 1/2. Then to finalize this, I can multiply the roots. Notice that I can multiply, and this is going to multiply whatever is inside. This is going to be here a square root of 6 minus a square root of 2, and then it's going to be divided by 4. So that'll be the end for this one. We can kind of make the same thing for the cosine of 15. We can do cosine of 45 minus 30. And of course, using the double angle identities here, this is going to be cosine of 45, cosine of 30, since this double angle identity is cosine by cosine, minus sine of 45, sine of 30. We're essentially using some of the same quantities that we had before. So this would be square root of 2 over 2. And this will be here square root of 3 over 2. The minus, this is a square root of 2 over 2 again. And sine of 30 is going to be 1/2. So the result is pretty much the same. Sorry, because there's a minus here, so this is going to be a plus. And so this is going to be square root of 6 plus a square root of 2 divided by 4. Now, tangent of 15, there's two ways that you can do that, but the first thing is you got to remember that this can be seen as sine of 15 over cosine of 15. So simply because we calculated those values before here, then we can just make the quotient between those two, square root of 6 minus the square root of 2 over 4, sorry, and the square root of 6 plus the square root of 2 over 4. So the ratio here between these two things is going to give me square root of 6 minus the square root of 2 over square root of 6 plus the square root of 2. And so that'll be the end of this question. Now, question 7 is very similar to a lot of the questions that we've been doing in this last part of the course. We have a pen that is divided into sections, and we see the diagram here. The dimensions of the pen are labeled. And we have that we only should use 100 feet of fencing for constructing this pen. Now, we want to find the dimensions of the largest possible area. Now, the area of this particular pen is going to be L times L plus W. So very initial pen construction. Now, the perimeter though, the perimeter is supposed to be L, 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 so it's going to be 3L. But we also have 4 and 5, so it's going to be 5L plus 2 times W. Now that should be equals to 100, because we want to use all that for the perimeter. And so this is going to give me, if I put everything in terms of W, this is going to give me 100 minus 5L divided by 2. Now I can use this piece of the formula and put it in here, and so now this is going to give me a new area. This is L squared, and then plus L times W, but W is going to be 100 minus phi L over 2. So if we simplify this a little bit, we're going to get a quadratic function. This is L squared plus 100 in L over 2, or 50L if you will, and this is going to be phi half L squared. I can think of this as 2L squared over 2, so at the end this is going to be minus 3 halves L squared plus 50L, and this is the quadratic formula that we're using. At this point we can use anything like Desmos to find out what is the maximum. And so if you go to Desmos, you're going to find out that this is a quadratic function, and the quadratic has a vertex that is giving me the maximum. That vertex is in the point 1647, and it's correlated to an area 416.67. So that will be the maximum area, 416.67. And it will occur with a length of 16.47. Now you can calculate with this 1647 in W, and you can plug the value 5 times 6.47 and divided by 2, and you're going to be able to calculate how much W is here in this dimension, which will be 8.25. And that pretty much concludes question number 7. Now for question 8, we have the surface of a sphere. And you gotta remember that the surface of a sphere is given by this function, 4 pi r squared. We want to determine the formula for the average rate of change of the surface of the sphere. So pretty much the first thing that we calculate is the delta S, the change of the surface area. And that's going to just be the change for two surface area when we're changing the radius. The radius here is increasing, so what is happening is that I have a change in the radius. So S2 minus S1 is going to be 4 pi R2 squared minus 4 pi R1 squared. Now if I factor this out, this is 4 pi, and I'm going to get the difference of the squares, R2 minus R1 squared. And if I factor this more, then I get 4 pi times R2 plus R1, and R2 minus R1 from the difference of the squares. Now notice that this means that delta S is 4 pi R2 plus R1, and this is delta R. And then we can divide, of course, by delta T. So ds dt is going to be 4 pi R2 plus R1 dr dt. And so that's completely going to give me what this is. Now in B, it says what is the average rate of change for the surface area of the sphere when the radius increases from 4 to 5. And so at that point, what we're doing is plugging in r equals 4 and r equals 5 here. And remember that the ratio is moving at 0.25 inches per second, so we actually have this value too. So we have ds dt is 4 pi. I have the two radius, 4 and 5. And this is being multiplied by 0.25. If I find out what this means, this is going to be around 28.3, and this is inches squared per second, since it's a measure of area that is increasing per second. Okay, so that will be the end of question number 8. Now for question number 1, this is one of the classic trigonometric relationships that we can do. And we have certain values. We have the values of cosine of x, and we have the values of sine of y. So as you can probably guess, what we need to find are the opposite values. So we are going to make some triangles. For this triangle here, let's make it with x. And so if we make the one with x, this is like 1, the adjacent, and the square root of 5 is going to be the hypotenuse. And so if we think of that in this way, then we can do square root of 5 square is equals to 1 square plus y square, where y will be, well, let me call this with a different name. Let me call this b, so it doesn't confuse with the coordinates. So we have square root of 5 square is equals 1 plus b squared. So this is 5 minus 1 is going to be b squared. And so 4 is b squared. And so b can be plus or minus 2. But now, because we have the information that x is in the second quadrant, we are here in the second quadrant, and this will be the equivalent, b will be the equivalent of the y coordinate here. And the y coordinate here has to be positive. So this is going to be a positive value, and b is equals to 2. Now with that, we have now the opposite, and so we can calculate for x, we can calculate pretty much everything. Sine of x will be opposite over hypotenuse, which will be 2 over a square root of 5. Now tangent of x is sine over cosine, and so sine over cosine will be 2 square root of 5 divided minus 1 over square root of 5. And so this means that it's just going to be minus 2. Now, what else? Everything else down here seems to be in terms of y, except for the sine of 2x here. So we can do sine of 2x at this point. Sine of 2x is 2 sine of x cosine of x. And that's just going to be twice 2 square root of 5 times minus 1 over square root of 5. And so that'll be minus 4 over 5. We can do the double angle identity, sine of x minus y and cosine of x plus y, but we'll come back to those once that we finish the rest. So now let's do the second triangle, which is a triangle for the information in terms of the angle y. We have a second triangle here, and we're getting the angle y here. And so this is saying that this is 3 over 4. So here is going to be 3, and the hypotenuse is going to be 4. So we calculate what that's supposed to be here on the adjacent. This is going to be 16 minus 9. And so that's going to be square root of 7. We're doing exactly the same thing that we did here. Okay? Of course, notice that y is in the first quadrant, so both x and y are positive, and that's why I'm concluding that this is positive too. So being this is square root of 7, then we can do adjacent over hypotenuse, and this is the square root of 7 over 4. And that'll be the cosine of y. Now cotangent of y will be cosine of y over sine of y. And so the cosine of y will be square root of 7 over 4 divided the sine of y, which is 3 over 4. So this means that this is a square root of 7 over 3. Now the secant is 1 over the cosine. And 1 over the cosine will be just 4 over the square root of 7. Now the cosine of 2y is just cosine square of y minus sine square of y. So because I already have those two values, I just need to make the square of them. So square root of 7 over 4 square minus the sine, which is 3 over 4 square. So this is going to be, of course, 7 over 16, and this is going to be 9 over 16. And so the answer here will be minus 2 over 16, which is like minus 1 over 8. At this point, we can finish with the double angle identities. And remember, the most important thing is that you state which are those double angle identities. This is probably going to be on your formula sheet, so the only thing that you need to do is to state it. So sine of x cosine of y minus cosine of x sine of y. And then just use the values that are here. So this is 2 over square root of 5, the square root of 7 over 4, minus 3 over 4, times minus 1 over square root of 5. We found these values earlier, so the only thing that you need to do here is just replace. And so this will be 2 square root of 7 plus 3 over 4 square root of 5. Now, for cosine, this is cosine of x, cosine of y, minus sine of x, sine of y. And so it's similar scenario. We have that now. This is going to be minus 1 over square root of 5 times the cosine of y, which is square root of 7 over 4, minus a sine of x, which is 2 over square root of 5, times the sine of y, which is going to be 3 over 4. Then we multiply the numbers that we just got, and we get minus the square root of 7 over 4 square root of 5, which is going to be a common denominator. And so this is going to be minus 6 over 4 square root of 5. And that's it. This is the conclusions of the questions for the final exam review.